Hey, what's going on guys, xiangqi here. So in this video I would like to demonstrate how the moves are generated for leaper pieces in our chess engine in 6502 assembly. So one of the major things I've changed is that from now on I'm using the natural wraparound for the integers. So if it again goes like beyond 250, like above 255 or beyond or below 0, it just wraps around. So I'm making use of this in order to simplify the code for remote generation, to add the offset, to add the step vector to the target score to calculate the newly obtained target score. So first I've actually I've tested this in my C version. So here these new numbers, so it's like no longer relying on the highest bit to represent this sign and now I have just the single line to add the offset, so I don't need to branch here. And this is also beneficial in the source code for the assembly program. So I'm currently working with a copy of the board, so this is just commented out, and here I have a single piece, and I would be demonstrating how exactly the moves are being generated for a single piece here. So what has changed since the last video? So I probably ended up by setting the step vector and storing it. Yeah, this is it. I've changed the place a word to skip from the loop in case if the step vector is equal to 0, and here down below we're just jumping up to the offset loop, so just a little bit more convenient doing things like this. And here, so this part of code sets up the destination score being equal to the source score for every particular offset, which is important. And now it's defined as the slide loop, but the slide loop is not actually yet on the card, so it's just a placeholder where it should be, because I'm not yet looping over the attack rate. So just once, just defining the target score is like once, not until it hits the board edge. So hence for leaper pieces, not for the slider ones. So what I do here, literally, I'm just loading the step vector and adding the step vector to the current value of the target score. So these two blocks of code does that, and then mark. So this is the debugging part. I just mark those scores that are considered to be the target scores for a current given source score for a current piece. Mark them with the value of 1. Right, so now without further ado, let's actually have a look how this works. I will test all the pieces first. Well, actually, not all the pieces. I would say all the piece types, because yeah, the type extraction should be working nicely. So starting from whites and then just for black pawns. So that should be fairly enough. All right, so we'll start by 0, 9. So let's put a white pawn here. Okay, and I assemble and upload 0200 and run, and the program completes here. I go into the hex dump. Then what we have here, here we have the following. So we got this is the board. Okay, so we got our pawn 09, and this is where it can go. So again, can go one step ahead and left and right diagonally. The matter of double pawn push would be the matter of pawn sliding along the attack rate, but that's going to be covered in the future videos, hopefully. So we have exact 3 offsets for white pawn that we're supposed to see here. Okay, so let's now go for this one, for knight. So here I just say knight, assemble, upload 0200 and hex dump. Now you see this knight and all the 8 directions where it goes. Note both are positive and negative. So all these 9 directions are currently working. Then the bishop 0D is the bishop 0D. So assemble, upload run hex dump. Oh, done something wrong. Okay, so the bishop is going diagonally, so here, 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 and here. I hope you see it. And then the rook 0e, and then the rook 0e, assemble 0, upload 0200, hex dump. And we have the orthogonally moving rook. So, well, obviously it's not sliding yet, so this is about to be sliding. So yeah, probably should focus on the leaper pieces instead of all of the pieces. But anyway, it's a matter of checking the offset, so this might be on the cards. So the two last, no, not last, but okay. So I want to check for F and for B. So F stands for queen, B stands for king. So let's make it F. And by the way, not really sure, but if I just put B here, is it going to define for, make it for both? Currently, because I'm just messing up the board array, I'm not 100% sure if this is gonna work. I didn't yet test this, to be honest, but anyway, let's give it a try. So I'm really curious to see if this works or not. Okay. And indeed it does. So you see, like, queen goes to all of the directions, and as well as the king goes to all of the directions as well. So the very last thing is the black pawn, right? So here, if I just make it a black pawn, nothing here, and don't forget to change the side, because otherwise it's not going to be detecting the piece, because it only detects those pieces that belong to the side to move. So assemble 0, upload 0200, run hex dump, and yeah, the black pawn is going downwards, which is exactly the case. Yeah, it seems to be working. So in the next step is to make the same thing but for slider pieces. So once we got a step vector, we need to loop over the attack rate until we hit the board edge. Then it would be some limitations, like if you hit the opponent's piece, if you hit your own piece. So lots of things, but for now it's fairly enough just to stop when it hits the board edge. So the next video I hope to implement it as well. This is from my side. Thanks for watching. Until the next time, and take care.